Okay, so this is what happened with the last one. Basically, if you want to be really perfect about this, and you don't have to be, your max height, that's your maximum height, the highest point it is up here, would equal, I'm going to do the capital H first, plus V naught sine theta squared over 2g. You don't have to do this, I just wanted to show you something. If you look at what we're given, you have your fundamental constant, which you can always assume to be given, your theta, hopefully you can see this, your v naught, your overall velocity here, and the height of whatever this thing was launched off of. So if you were making a spreadsheet, that would be like, that's what you would put. You'd put like height, like h in meters, if you had actual numbers for this, if you were measuring it from like, oh, say a paper catapult or something. Okay, you would do like V naught in meters per second, and you would do like G in meters per second squared, something like that. And this would be the stuff that you knew, and these would be what you put your numbers in, probably 10 here, and then whatever numbers you had, and you could do multiple trials, have multiple data point kind of things on this, and then you could solve for max height. You could solve for the late, you could solve for a lot of different things. So basically, though, we're distilling it down to these three. Oh, I guess I should also say these four things because I forgot theta. So see, but basically theta in degrees. And degrees are a unit of measure. So let's see how I'd have these four things. I could find out so much from this. I can find out the highest point it reaches. I can find out this h, just how far above the table it goes, or whatever that is. I can find out how far it went. I can find out how long it took, all from these four things. So that's why we solve things with symbols. Anyway, so you have that. Okay, so now let's find, since we found the maximum height this reaches, let's find the other things. Hopefully you can see that. Let's find the time, the time up. So I'm going to do this as time up. Okay, I'll just write that equals T-U-P. Okay, so let's find here, I'm going to put over here, we're going to find the total time in air, or sometimes you'll see it as airborne. So total time in air, so it would be your time up, and it'd also be your time down. So that total time in air would equal time up plus time down. Let's find the time up first. So if you look, you've got one, we're missing time, that's what we're looking for, 2, 3, and remember now we have h. So you got 4 different things right here. So you totally can find the right thing. So let's look at the kinematic equations. Well, we're looking for time, and we've got everything else, so this one's the easiest one to use. So I'm just going to copy it real quick. Okay, so actually I'm going to change this to minus. I'm going to do that in a different color. I'm going to change this one to minus and this one to g, because we know that the acceleration is negative g. And then we know that final velocity, because we're still going on the trip up, is 0. So we can say this. Therefore, negative velocity initial equals negative gt. I forgot to make this one into a g, sorry. So then we just divide by negative g. The negatives go away. So therefore, time up equals, well, let's see, your initial velocity is v naught sine theta over g. Go write that. Actually, let's just draw a line. Okay, so that's the time up. Now let's look at the time down. And what I'm going to do for this is, for the downside, I'm going to, I should probably just erase these. I'm going to organize my information again and just do it as a separate problem. So we'll have, let's look at this. This is for down. Let's look at the information that we have. So x Remember, they share time. You still won't have acceleration this way. Your acceleration this way will still be negative g. Time, we don't know. It's going to be like the first thing we find. Now, your initial velocity this time, if you look, you're falling from the top. This is a lot like the horizontal velocity problem we did over the weekend. So now your initial velocity is 0, which actually makes this a much easier problem. Your final velocity. Your final velocity, this is your overall final velocity, just like the narrative problem thing. And then, so your velocity going down, don't forget your arrows, this would be your VF. So negative, and we don't know it. So I'm going to put negative question mark, just put in the negative to remember you fall down. And then let's call this, you actually do know, I'm going to call this SY, you actually do know that. This is your max height. Line. This is your max height right here. So that would be, I'm just going to put it's h plus capital H. I'm not going to write all of this stuff out because remember we said it was little h plus big H up here. So that's your max height right there. So we did know that. Now we got Vx and you have your call this S sub x1, I'm going to call this S sub x2. I guess I could call it range or whatever else. I'll call that 2. Now look, remember, your velocity in the x direction will not change at all. There's no acceleration, so it stays v naught cosine theta the whole time. And then this you don't know, but you know it's going to be positive. Oh, and all of this right here, you know it's falling down, so it's negative. So let's look. How can you find your time here? Well, you got 2 out of your 3. Okay, so you got 2 out of your 3. We know we're looking for time, so that one goes away. Okay, we know we're also missing final velocity, so that one goes away. Now, I had some people ask me if this is okay that this says x and we're dealing with the y. It totally is. X is just like the general form of position. If it makes you feel better, you can change these to y. Just make sure you change this to negative g while you do that. I'm going to go ahead and do that. Because the negative that way. Okay, so if you subtract, that'll give you, look, that's just your displacement. So I'm going to say, we're calling that SY, which is actually equal to your maximum height, which we do know, equals, oh yeah, your initial velocity is 0. So negative SY equals negative 1/2 GT squared. Okay, your negatives go away. And I'll switch colors real quick. Your negatives go away, so let's solve this. And remember, this is also just like, I'm gonna scratch that out. This is also just like GT squared over 2. To get half of something, you divide it in 2. So you're gonna have 2, 2, and then also you're gonna divide by G. This should look familiar, so therefore, time squared equals 2SY over G. And then of course you do the square root to get rid of that, square root both sides. What I'm going to do here, I'm kind of running out of room. You could just put in h, 2 times h plus capital H, and you'd want to put those in parentheses. You can also go ahead and plug in all of this if you want. You don't have to though, because this would be something ultimately we'd put in a spreadsheet. So that would be your time down. So now we have time up and time down. And just delete this. Okay, I'm going to delete all this too, because hopefully you got all of that. Sorry. Okay, so now I'm going to, I'll just do this in another color. Time up is, I'm getting that from over here. I guess I shouldn't have erased that. V naught sine theta over G. All right, plus, and then this one down here, the square root of 2h plus h over G. And that is your time total. I'll just write time total, abbreviate total. And so that would be for your time. Now, you, for tomorrow, need to find the range, the overall range. You do it just like the time.